Hey, it's Mr. Barr, and let's see if I remember how to do any trig. So before we get too crazy, I'm going to give you the 3 basic trig functions, and hopefully they're right. So if I have a triangle, let me draw a triangle here. And it needs to be a right triangle. And if I have some angle right here, such as, let's call this angle A. So in relation to angle A, there are 3 sides. This side is the hypotenuse, which you know from Pythagorean Theorem. This side over here is called the opposite side, and this side over here is called the adjacent side. And then the 3 trig functions are sine. So sine of A equals opposite over hypotenuse. Tangent of A equals adjacent over hypotenuse. And then, this should be cosine. Cosine of A. Cosine of A is adjacent over hypotenuse, and tangent of A is opposite over adjacent. Okay, let's see if that actually makes sense with the IXL. So working on this one right here, it wants to know what is tan of E. So tangent is opposite over adjacent, so it's going to be 12 divided by 5, which is 2.4. Brilliant. It wants to know tangent of x. Tangent of x is opposite over adjacent, so 45 over 28, which is 1.61 nearest hundredth, so 1.61. I'm making sure I've got my rounding right. Excellent. Cosine of k. Okay, k, cosine is adjacent, so 36 over hypotenuse, so 36 over 85, which is 0.42. And if I get this right, then I'm good. Okay, good. I've got my little notes over here correct. Thought I might have mixed up sine and cosine. Cosine of y is going to be, cosine is adjacent, so 48 over 73. So that's going to be around to 0.66. All right, I'm happy that I've gotten the basic notes correct. I'm going to jump a level, see how it changes. Tangent of P. Ooh, do you see what it's doing? Interesting. It's forcing us to use the Pythagorean Theorem. Tangent is opposite over adjacent, but I don't have the adjacent. So I'm going to have to use Pythagorean Theorem. Remember Pythagorean Theorem? I hope you do. So Pythagorean Theorem, we're going to get in here as a squared plus b squared equals c squared. So this is a 3, 4, 5 triangle. So this guy right here, RQ, is going to be a 4. So opposite over adjacent. I don't want to write on this because then I'm going to lose all my notes, but okay, we'll give it a shot. I don't want to write on this, but I will. So so a squared, so 3 squared plus b squared equals 5 squared. 9 plus b squared equals 25, right? B squared equals 16, b equals 4. Okay, Pythagorean Theorem. And now I'm going to do tangent, and I know that tangent is of whatever it is, p, is opposite over adjacent. Tangent is opposite over adjacent, so 4 over 3, which is 1.33. Hundredth, good. Got it. same thing. I've got to use the Pythagorean theorem, and then I can solve this. Okay, so it's going to be 17 squared minus 8 squared, which gives me 225. So this side right here is 15, and now I'm doing tangent of A, so opposite over adjacent, so 15 over 8, which is 1.88 with the rounding. Cool. Another Pythagorean theorem, so we're going to skip a level. Let's jump up and see what we get up here. So just a weird Pythagorean theorem. Let's do it. All right, so we know that a squared plus b squared equals c squared. Well, a will go with the square root of 11 squared plus the unknown side, b equals the hypotenuse, which is 64. So 11 plus b squared equals 64. B squared equals 53. Ooh, I do not like that answer. Sam, I am. 53. I do not like that answer. 53 squared This is A, B, C. A squared, which is 11, plus B squared, which is unknown, equals C squared, which is 81. So B squared, really, so is B, do I have to take the square root of that? Square root of 53? I do not, 7.28? There's something weird here. Tangent, so this is 7.28. So the tangent of V is opposite over adjacent. You know what it is? It's, you know, this isn't too bad. It was going to be weird anyway. So it's going to be, so it's the square, it's 7.28 over the square root of 11. It's going to lose it on the rounding though. 7.28 divided by the square root of 11. I get it as 2.102. Ah, my goodness, 2.20? I'm going to try it another way. It would be the square root of 53 over 11. That's another way of looking at it. Square root of 53 divided by 11. Yeah, I'm getting 2.20 again. 2.20. Oh, I do not like this answer. And 2.2. I want to know if they would give it, if they would mark me wrong if I just put 2.2. I got it. Okay, Mr. Barr, you're brilliant. That's some craziness right there. I'll do another one of those. Okay, so we've got to find the hypotenuse. So it's square root of 37. I forgot to write a 37. Excuse me. Okay, so square root. Square root of 37 squared plus 5 squared equals the hypotenuse squared. So this is 37 plus 25 equals the hypotenuse squared. So it's 37 plus 25, so 62. So the hypotenuse squared equals 62, so the hypotenuse is the square root of 62. So this is the square root of 62. Cosine of y. Cosine is opposite over hypotenuse. So opposite 5 over the square root of 62. Using a calculator, 5 divided by square root of 62, 0.64. .77. Where did I mess up? Oh, it was adjacent. Did I go opposite? I did. Cosine, sine is up. I messed it up. I did sine. Okay, I got it. That's why I need those notes in front of me, the ones that I erased earlier. Sine, cosine. Okay, we're gonna jump a level. Okay, we're back to the square root ones. Oh, I don't have to use Pythagorean theorem on this one though. Okay, so this guy is going to be, what am I doing? Sine of I. Sine of I. Sine is opposite over hypotenuse. Square root of 37 over the square root of 73. Let me get my lights to come back on. All right, so square root of 37 divided by square root of 73. 0.71. Okay, nothing crazy here. Let's jump a level. Yeah, we're back to the Pythagorean theorem with square roots. I've already done something like this. Let's jump a level. Okay, now it's just having me do all three. Okay, nothing crazy there. I'll do this one just for fun. Okay. Sine of t. Sine of t is opposite over hypotenuse. I've got to use Pythagorean theorem here. 3 squared plus the unknown squared equals 4 squared. So 9 plus that equals 16. X squared equals, what's that, 7? X equals the square root of 7. Pythagorean theorem. Cosine. Cosine of t is adjacent over hypotenuse, so square root of 7 over 4. And tangent is opposite over adjacent, so 3 over the square root of 7. So I've got point. This one's going to be 0.75. Square root of 7 divided by 4, 0.66. And tangent 3 divided by square root of 7, 1.13. Terrific. All right, that's it. Oh, look at that one. I have, you know what? I'm going to do the Pythagorean piece of this at least. So the Pythagorean piece of this is, I have the hypotenuse, so 2 square root of 6 plus x squared equals 2 square root of 21. Okay, 2 square root of 6 squared. This becomes 4 times 6, which is 24, plus x squared equals, this becomes 4 times 21, which is 84. So x squared equals 84 minus 24. X squared equals 60. X equals the square root of 60. There you go. And from there, do normal sine, cosine, tangent. That's it. Thanks for watching.